Hello dear students. In this video, we will learn about conservative two-phase locking protocol. Just observe that the word conservative here, if understood, then the entire procedure would be very easily understood. By the way, conservative 2PL is also known as static two-phase locking protocol. What's the simple rule used by this protocol is that whatever locks a transaction needs, just check my words, whatever locks the transaction needs, the transaction must acquire those locks before even starting execution. What I mean is, let's say that transaction T1 wants to read A. I mean that are the operations in this transaction. Then it wants to read B and also write B. That's it. These are the operations done by T1. Then which locks does T1 need in its lifetime? From start to finish, which locks T1 needs? T1 needs shared lock, shared lock on A because it is reading A, correct? But it needs exclusive lock, exclusive lock on B because it is reading and writing B. So this is the set, you can say this is the set of locks which are needed by T1. So what T1 must do is it must acquire all these locks before it even starts. Before even the first statement of T1 runs, these locks must be acquired. All the locks must be acquired. Only then T1 can start. This is true about all the transactions running in the schedule. If T2 is also reading A and T2 is reading C and writing C, then which locks does T2 need? Shared lock on A and exclusive lock on C, isn't it? These locks must be acquired before T2 starts. So T2 must try to acquire these two locks, and once T2 is successful in acquiring all the locks that it needs, only then T2 can start. So conservative is that T1 says, look, if I have all the resources, only then I am going to start. Whatever locks I need, if I get them, only then I am going to start. Otherwise, I will not even begin my execution. There are two types of sets defined by any transaction: read set and write set. Name itself is self explanatory. Suppose T1 wants to read A, T1 wants to read B and write B. Then in the read set of T1, A is present because T1 is trying to read A. And in the write set of T1, B is present because T1 is trying to write B. Of course, T1 is reading B, but the important or bigger operation is write B. So you can observe that which type of lock T1 would need. It would need shared lock on A and it would need exclusive lock on B. This can be the importance of read set and write set so that our transaction management system understands that which locks are exactly necessary by a particular transaction. Now, just imagine that there is an example here as follows. Check these two transactions, T1 and T2. Now you can see there is no locking or unlocking done anywhere in these transactions. Then where will be the locks acquired? Yes, before even the transaction starts, the locks will be acquired. So which locks does T1 need? Let's write them in order. T1 needs shared lock, shared lock on A, correct? And it needs exclusive lock, exclusive lock on B. And which type of locks does T2 need? It needs again shared lock on A, isn't it? Shared lock on A and exclusive lock on C. Now these locks must be acquired before even any transaction starts. I hope you are understanding. Now this type of two-phase locking protocol will all, oh yes, one more thing. These locks are acquired, I said, before the transaction starts, and the locks are released only at the end of transaction. So when the transaction commits, and then only the unlock procedure starts. Basically, transaction management itself takes away all the locks when the transaction ends. So we don't have to write only any unlock operation here. It is understood that these locks which were acquired by T1 before the transaction started, these locks will be automatically released when the transaction ends. Now let's understand how exactly deadlock is going to be removed by a conservative two phase locking protocol. Just see, there are two transactions again, T1 and T2 over here, correct? And T1 is reading and writing A, observe, and also reading and writing B. Same thing is getting done by T2. T2 is also reading, writing A, and T2 is reading, writing A, correct? So which type of locks does T1 need? T1 needs exclusive lock on A and exclusive lock on B, correct? Same thing is needed. Exclusive lock on A here, exclusive lock on B. Just check this, isn't it? Because both the transactions want to read and write A. Now, what I want to explain is that in this type of system, that is conservative 2PL, deadlock won't occur. Let me write this acquiring of the locks again over here in detail, so that we understand how deadlocks won't happen. Okay, here we go. T1 and T2. T1 will try to lock A, exclusive lock, and also try to lock B, exclusive lock. Same way, T2 will also try to lock A, exclusive, and B, exclusive. Let's say that T1 locks A and it is successful in locking exclusively A. And then T2 also tries to lock A, okay, exclusively. But how can T2 get this lock now? Isn't it? It can't, because it has been already acquired by T1. So T2 won't even start. Yes, because T2 has not got all the locks that it has acquired. And then T1 continues to get another lock on B, and T1 continues. Now these locks will be released. These locks will be auto released when T1 ends, and then T2 gets all the locks and continues its execution. Just try to understand it in a better way. Let's say again with our reference T1 and T2, you know T1 tries to lock A and B. Just imagine the sequence of locking is like this: lock B and lock A. This is in reference with our transaction that written, we have written over here, isn't it? Read A, write A, read B, write B. So both transaction wants A and B. And the sequence with which T2 locks is, let's say, lock X A and lock X B. Just imagine both these transactions try to acquire their locks, but exactly in reverse order. It might happen. Then imagine that T1 locks B, exclusive lock, and imagine T2 locks A, exclusive lock. Oh, good Lord, look at that now. T1 has locked B, T2 has locked A. Now coming back to T1, if you look at T1, how can T1 get lock on A? Because lock of A is with T2. I hope you are understanding. And look at T2 now. Look at this operation. It can't lock B because that lock is with T1, isn't it? So what happens? Are they deadlocked now? Are both waiting for each other? No. What did we say? If the transactions are not able to get their locks, then transactions won't even start. What it does, T1 says, anyway, I am not getting a lock which I want. So I will release all the locks that I till now acquired. So whatever locks it has, it releases immediately. And same thing is done by T2. T2 says, I am not getting all the locks. So whatever locks I have received till now, I will just release them. Great. That means now both the transactions say, okay, anyway we can't start. So what's the point in acquiring half of the set or half of the locks, and we need not wait for half of them? So if we are not getting all the locks, we won't start. And not only that, we won't start, we will release all the locks that we have taken. Then the whole story can start again. T1 can try to acquire lock, T2 can try to acquire lock, and there will be a time, where both these operations will run in such a way that these locks have not been acquired yet. These locks have not been acquired yet, and both the locks necessary by T1 or both the locks necessary by T2 are acquired successfully. I hope you have understood. In short, I would tell that transaction always acquires all the locks it needs before its execution. And if it is unsuccessful in getting all the locks that it needs, then it won't start, the transaction won't start. And not only that, it will release all the locks that it has acquired till now. So that's what is conservative 2PL, and it gives freedom from deadlocks. So you can see the 3 points about conservative 2PL. It is serializable, first of all, just as our earlier 2PL, strict 2PL, and rigorous 2PL. All these protocols ensured serializability. It is cascadeless. Remember, strict 2PL, rigorous 2PL produce cascadeless schedules, and even conservative 2PL produce cascadeless schedule. But big advantage is it gives freedom from deadlocks. But there is one disadvantage. That's why conservative 2PL is not used. In actual practice, strict 2PL is enough. What is the disadvantage is it's very difficult for a transaction or for a designer of the transaction to every time make read and write set. Obviously, you are writing transactions, you want to transfer money from one account to other account, or you want to cancel a railway reservation ticket. As a transaction designer, as a programmer, if you are asked to define read set and write set every time when you write transaction, it's going to be a very, very big or an extra work imposed on the programmer. So that's why conservative 2PL is not used in reality. But anyway, it is one of the protocols that we have seen. Thank you very much.